Okay, here's our math video. It's not a geography video. You're seeing southern Italy, you're seeing Greece, you're seeing North Africa. This is a video on the Pythagorean Theorem, and we're going to talk about Pythagoras. Pythagoras lived about 600 years before Christ. He lived in southern Italy, and at that time southern Italy and Sicily were part of Greece. So we'll talk about Pythagoras. So today is the Pythagorean Theorem. So here's the Pythagorean Theorem. A little blurry, let's get that fixed. There we go. And it's a squared plus b squared equals c squared. We use the Pythagorean Theorem for right triangles. Keep that in mind, right triangles. Now, we talked about Pythagoras before. One of his students we talked about, Hypasus or Hypasus, however you want to say it. Some people say Hypasus, some people say Hypasus. And remember, Hypasus said he was the one who discovered, or so they say, the myth goes, that he discovered irrational numbers and died because of it. People thought that that was crazy, that there could be irrational numbers. And we talked about irrational numbers. So I underlined theorem because a theorem is not a theory. A theorem is a statement that has been proven. A theory has been supported with tests. You know, a lot of tests have been done, and there's a lot of evidence that the theory is true, but it's not been proven. Or, in other words, it hasn't been disproven also. So a theorem is a stronger statement that has been proven. So here it is, a squared plus b squared equals c squared. Okay, and then we have Pythagoras, which I said lived about 600 years before Christ. A lot of people put it as circa 580 BC, so he lived a long time ago. He lived before Aristotle, he lived before Plato, Socrates, those famous philosophers. People call him a philosopher. Pythagoras believed that everything in the world revolved around numbers. And he lived in Metapontum, and Metapontum is in southern Italy. We talked about that before. There's a better map to understand it. Maybe for some extra credit here. So in this area right here, this was all ancient Greece, Magna Graecia, they said. And so Metapontum would have been around here somewhere in Calabria, but he also lived around this area in southern Italy. So that's a little extra credit. So with the Pythagoras, with the Pythagorean theorem, it's always with right triangles. That's what we're dealing with. That's what we use it with. So we have certain, let me write the theorem here. It's a squared plus b squared equals c squared. And we have certain vocabulary here. We have, these are legs. That's leg A, that's leg B. And this is C, and C is the hypotenuse. So I'll put an arrow here. The hypotenuse. Some students remember it by saying hippopotamus, right? So the hypotenuse is the longest side of a right triangle. It's the longest side. It's also opposite the 90 degrees. It's opposite. So whatever line is opposite the 90 degrees is the hypotenuse. And again, the hypotenuse is the longest side of a right triangle. Okay, so let me write the formula again. A squared plus b squared will give us c squared. And we're going to use this because we can find any length that's missing in a right triangle. Right? And there's another way of doing it. We can say the square root of a squared plus b squared will equal c. And I'll show you both ways. But most of the time, this is the most famous one. They're both the same thing, but this one could be easier, the second one. We'll do both. So let's take an example here. Let's say that we knew that this was 3 units, this was 4 units, and we want to know what c is. And so we can use the formula. So we'll say a squared plus b squared equals c squared. So we can make this a, and we can make this b, leg A, leg B. So if a is 3, a squared will be 3 squared. And if b is 4, it would be 4 squared, and it'll give us what c squared is. let's move this over. So we know that 3 squared is 9, 4 squared is 16, so that means c squared must be 25. Now, we're not looking for c squared, we're looking for c. So if c squared is 25, remember with square roots, the square root of 25 gives us c, which would be 5. So whatever answer you get for c squared, get the square root of it, and there's c. Let's do a few others. Okay, let's make another right triangle here. Now remember, we need that box to show that it's a right triangle, otherwise it's not. And let's say that leg A, this is leg A, you don't have to write leg A, but let's say leg A was 6, and we're saying B now was, let's say, 8. What's C? So try that with the Pythagorean Theorem. I'll write it up here. A squared plus B squared equals C squared. Try that, see what you get. Okay, so let's move that over. So we're saying A is 6, so A squared, 6 squared, will be 36. We're saying that B is 8, so 8 squared is 64. And that'll give us our answer of C squared. C squared should be 100. But again, we don't want C squared, we're looking for C, so the square root of 100 will give us C, 10. Now let's look at it in a different way. So remember I said we can also use, if we square right away, A squared plus B squared, we'll just get C right away. So we know, if we look at the, let me write it up here. Remember we had 6 and we had 8. So we had the square root of 36 plus 64. And we know that is the square root of 100, and that gives us C right away. So you can do it both ways. Let's do another. Yeah, there's this. Make a right triangle here. Don't forget the box. By the way, they don't have to look like this. They can be any way. You know, it could look like this. Be upside down. It doesn't matter. Because you know that the hypotenuse of the right triangle is opposite the 90 degrees. So that would be C. There's A and there's B. And it doesn't really matter where you put A or B. So let's say we had this. We had it upside down. Let's say we had A was 9 units and B was 12. Find C. Try that. Okay, so again we have A squared plus B squared equals C squared. Or you can just do, we'll do it over here, or you can do this, the square root of A squared plus B squared will give us C. Either way. So if we have 9, so A squared, 9 squared gives us 81, so we have 81. And then 12 squared is 144. Let's bring that up. So this will equal, and if we did the square root of this, it will be the square root of 225. And we know the square root of 225, bring that up again, is 15. So C will be 15. Now, if we did it the other way, bring this down here, we said A squared plus B squared equals C squared. I'll erase this. And we said 9 squared plus 12 squared will give us C squared. So 9 squared is 81, 12 squared is 144. So C squared will be 225. Again, we don't want C squared, we just want C. So the square root of 225 is 15. So that's both ways. Now, we don't have to look for B. I mean, at C, we can also look for other legs too. Let's say we knew, we'll have these, and let's say we knew A and B, or A and C, and we don't know what B is. We can do something like that. For example, before we had 3, 4, and we said C was 5. But let's say we didn't know what B was. I'll erase that. All we can do is say that B is missing. We don't know what B is. Well, we can do the same thing. Let's bring that over. We can say now that A squared plus B squared is still C squared, right? We have A squared. That's 9. We don't know what B squared is, but we have C squared, 25. So we have everything there. We're just missing B squared. This is just algebra. Whatever you do to one side, you do to the other. So we're going to minus the 9 out. And we're saying B squared equals 16. So if B squared is 16, what's regular B? Without an exponent. The square root of 16, which is 4. So it doesn't matter if you're trying to find A, B, or C. As long as you have A, or as long as you have two of the sides, you can get the answer. So here we have one way of doing it, which we've done already, where you can just get the A squared plus B squared, the square root of that, and you'll get C, or you can just do it A squared plus B squared equals C squared. Now this should be familiar to you. We did this in another video when we were talking about irrational numbers and Hypotenuse. So again, if we had a right triangle with a diagonal of a square, and the hypotenuse will always be the square root of 2. And we can prove that again because we said A squared plus B squared equals C squared. And we had 1 squared is 1, and 1 squared again is 1. So C squared has to be 2. So the square root of 2 will give us C. Okay, let's bring another one up here. So now, you may have been seeing a pattern, and there's something called Pythagorean triples. So I'll write that there. And it's another way of finding a side of a triangle. So let's just do, this is the most famous triple, the 3, 4, 5. And this could be a base for solving any one. All you have to do is to get another triple, to find another one. It's just multiply each number by the number. Like let's say 2. 3 times 2 is 6, 5 times 2 is 10, 4 times 2 is 8. So there's another triple. Right? So let's say I did, and then we did, let's say times 4. 3 times 4 is 12. 4 times 4 is 16. 5 times 4 is 20. There's another triple. So that's another way of trying to find a side of a triangle using Pythagorean triples. So let's use that logic to try to find a missing side. Okay, so I'll erase this. Okay, we'll make a right triangle. And let's say that we had 35 was here, and we had 28 here. What do you think A is? Now we can use the Pythagorean theorem, or we can think about Pythagorean triples. And to think about that, always think of the base, the 3, 4, 5. Think of the 3, 4, 5. So how did I get 35 with 5? And how did I get 28 with 4? Well, 7 times 5 is 35. 7 times 4 is 28. So 7 times 3 will give us A, 21. So that's using the Pythagorean triples. So that's the Pythagorean theorem. We will talk more about the Pythagorean theorem. We'll prove it in future videos. Great job.